So question 4a, part 1, prove that cos 2a is equal to cos squared a minus sine squared a. So we're going to need our log tables here for this. And in order to solve this or prove this, I'm going to use page 14 in my log table. So it's handy to have them in front of you so you know where the information is coming from. So on page 14 in the log tables, in order to solve this, I'm going to use cos a plus b. So this is the compound angle up the top left-hand corner of the log tables, is equal to cos A cos B minus sine A sine B. So that's what I'm going to use here. Now think about this for a second. If we were to look at what they're asking us, cos 2A. Now 2A is the same as me just going A plus A. So that's the same thing. Sorry, I'm putting in a B, but it should be A plus A. So 2a is the same as a plus a. So think about like 2 5s is the same as 5 plus 5. It's 10. So that's the logic I'm using here. So if I use that here now, and all I'm going to do basically is I'm going to sub in capital A for A. Again, I'm using this part here. And I'm going to sub in capital A for B because I'm going for 2 times A. So that's just going to give me basically cos, subbing in A, cos A. Subbing in A for B just gives me cos A again, minus sine A, and then I sub in A for sine B. And when I multiply cos A by cos A, I got cos squared A. And when I multiply sine A by sine A, I get sine squared A. That's basically what they wanted us to prove. So that's cos A plus A, which is the same as cos of 2A. And that's it. It's simply put as that. Having a look at a part 2, sine theta over 2 is equal to 1 over the root of 5, where theta, which is the angle, is between 0 and pi. So pi here in this case is radians, 180 degrees. So it's important here that they're not allowing us to solve this in any way we want. It's asking us that we must use the formula cos 2a is equal to cos squared a minus sine squared a to find the value of cos theta. So we have to use that. So like we said, we must use cos 2a is equal to cos squared a minus sine squared a. Now the question is talking in terms of theta, so I'm just going to change my a there to a theta. So I'm looking at cos 2 theta equals cos squared theta minus sine squared theta. So that's the first thing I'm going to do. The next thing is that you can look at our angle here. Our angle is actually theta over 2, not theta. So let's have a look at how can we change our cos 2 theta. So that's the same as, instead of going, well, we know that cos 2 theta is cos theta plus theta. But my angle in this case is not theta, it's theta over 2. So if we look at it this way, I'm kind of working backwards here. So that's the same as cos 1 theta, which is basically cos theta. So I'm not working now with cos 2 theta, I'm working with cos 1 theta, or just cos theta. And that's now going to give me cos squared theta over 2, or a half theta, minus sine squared theta over 2. So that's basically where I'm going from here. Now what I'm going to look at is I'm going to use my knowledge of page 13 actually in my log tables. And from page 13 we know that sine squared a plus cos squared a is equal to 1. Now my angle in this case is theta over 2, so let's just change that. It's sine squared theta over 2 plus cos squared theta over 2 equals to 1. I'm just changing my angle basically. Now what I want to do is I'm going to basically write that if we were to subtract sine squared theta from both sides, or in other words moving it over, I would get cos squared theta over 2 is equal to 1 minus sine squared theta over 2. So what I'm going to do now is I'm going to substitute in 1 minus sine squared theta over 2 for cos theta over 2. So now I have cos theta is equal to, and instead of calling it cos squared theta over 2, I'm actually going to call it 1 minus sine squared theta over 2. Subtract sine squared theta over 2. Taking that out of the bracket gives me cos theta is equal to 1 minus sine squared theta over 2 minus sine squared theta over 2. And the reason I'm doing that is, again, just actually, if you're thinking, why did I move the sine over to the right hand side? If you think about at the question here, it's asking us to find the value of sine theta over 2. So I'm thinking in my head, okay, my answer must have sine in it, and that's why I wanted to eliminate the cos. So just if you're kind of thinking which one I moved, that's the logic behind that. So now I have cos theta is equal to 1. Well, I have two of these now. So minus sine squared theta minus sine squared theta gives me minus 2 sine squared theta over 2. So think of that like sine squared theta over 2 as an x. So it's minus x is minus 2x. So just try and think of it like that. And where can I go from there? Think about up at the top of the question here. We know, so let's just box off some of this rough work here. So that's my first part. That was for in here. The next thing I know from the top of the question, this part, I know that sine theta over 2 has a value of 1 over root 5. That's what they're telling us. So what I'm going to do now is I'm going to substitute in 1 over root 5 where I have sine theta over 2. Now we just need to make sure that it's squared. So I need to square my value here. So if I can get rid of all this now, that's going to give me cos theta is equal to 1 minus 2 times sine theta over 2, which is 1 over root 5. But like I said, it's squared, so I need to put a square on that. Multiplying that out then on my calculator or squaring it in my head will just give me 1 minus 2 times 1 over positive 5. So cos theta is equal to 1 minus 2 times 1 over 5. And that's giving me cos theta is equal to 1 minus 2 over 5. And 1 subtract 2 over 5 is 3 over 5. So the question wanted us to find, use your formula to find the value of cos theta. Well, cos theta is equal to 3/5. Scrolling down now to part B to that question. So solve the equation tan b plus 150 degrees is equal to minus root 3, where b is between 0 and 360 degrees. So again, let's put down what we know. So we have tan b plus 150 degrees is equal to minus root 3. I'm going to use my log tables now, page 14. And on page 14, it tells me that tan a plus b, again, don't mix up this a and b. They're completely different. One's just from the formula and one's from the question. So don't get confused there. So tan a plus b is equal to tan a plus tan b. So this is just the formula basically. Over 1 minus tan a times tan b. And I'm basically going to sub in I'm subbing in b for a, and I'm subbing in 150 degrees for b. So that's what I'm subbing in there. So that is that, and the b is 150. So that's giving me tan of b plus 150 degrees is equal to tan a, which now becomes tan b when I'm subbing in, plus tan 150 all over 1 minus tan a, which is now tan b, times tan of 150 degrees. Just make sure your calculator is in degrees when you're working out tan 50. So tan b plus 150 is equal to tan b plus minus 1 over root 3 divided by 1 minus tan b times minus 1 over root 3. Which is giving me, so let's just multiply out that bottom part, minus 1 over root 3 by minus tan b. So that'll just turn that to a plus, but let's put each step in individually. So that's equal to tan b. Taking this out of the bracket will give me minus 1 over root 3 all over 1 plus 1 over root 3 times tan b. Okay, so I've just tidied up the signs there, basically. That's all I've done. Next thing I'm going to do is that I know that the value of tan b plus 150 is minus root 3. So I'm going to sub that in now. So I'm subbing in minus root 3 for tan b plus 180. So that's equal to tan b minus 1 over root 3. I'm just stuck for space here now, so just scroll down. Actually, I'm running out of the page here. So use of a little bit of Tipex there. Tan b minus 1 over root 3 all over 1 plus 1 over root 3 times tan b. And I'm going to put the minus root 3 over 1, and then I'm going to cross multiply here. So fraction equals to fraction. So common denominator, basically. So it gets a little bit complicated there now. What's that going to give me? It's giving me minus root 3 times 1 plus 1 over root 3 tan b equals 1 times tan b minus 1 over root 3. And multiplying in my brackets, that's going to give me minus 1 root 3, or just minus root 3. Minus root 3 by 1 over root 3, well, that's just going to give me minus 1, isn't it? Times tan b is equal to, and then multiply in my second bracket, 1 times tan b is tan b, 1 times minus 1 over root 3 is just minus 1 over root 3. Actually multiplying in that 1, so let's just write it in, that just gives me minus tan b is equal to tan b minus 1 over root 3. Okay, moving tan b's to one side and numbers, constants to the other. So I'm going to add tan b to both sides and add minus 1 over root 3 to both sides. So what does that tidy up as? That's then going to give me minus root 3 plus 1 over root 3 is equal to tan b plus tan b. So minus root 3 plus 1 over root 3 is giving me, let's see, minus 2 root 3 over 3. And tan b plus tan b is 2 tan b. I'm then going to divide both sides by 2, which is giving me minus 2 root 3 over 3. I'll write it like this, divided by 2, instead of going a double fraction, is equal to tan b. And when I divide that by 2, I get, still stuck for space, let's come up here, I get minus root 3 over 3 is equal to tan b. I'm looking for the value of b, so I get tan inverse of minus root 3 over 3, which is giving me b is equal to minus 30 degrees. Now, if we scroll back up to the top of this question, it wants the values of b between 0 degrees and 360 degrees. So we need to focus in on that part now for a second. So what we're going to look at here is, let's just zoom out a little bit. So if we were to use our knowledge of cast here, so we're looking at our XY graph, and we have cos positive in quadrant 4, all positive in quadrant 1, S sine positive in quadrant 2, and T tan positive in quadrant 3. So minus 30 degrees is down around here. That's our negative 30 degrees. Now that means, don't forget, our solution here for tan is negative. So where are we looking for? We're basically looking for values for tan is negative. So tan is negative here in quadrant 4, and tan is negative in quadrant 2. So we're using our reference angle here of minus 30 degrees. So if I'm looking for this angle here, where tan is negative, so this angle here will also be 30 degrees. So I'm going back from 180 back 30 degrees, which brings me to a full angle here of 150. So my possible solutions for B are 180 minus 30, which is 50 degrees, so 150 degrees. And I also could have, well, I could also have the angle where I am, the negative 30. But if I just add on a full rotation, 360 degrees brings me to here. So if I go 360 plus negative 30, or just go 360 minus 30, which brings me to 330 degrees. So they're my two values for B, 150 degrees and 330 degrees.